The last section is question number 7. Some of the trust animals are tortoises. Some are not. Some of the animals are known genders. Some are not. Let the set of tortoises be T and the set of animals of known gender be K. The number of animals falling into these categories are shown. We have 4 in the T only category. We have 20 in the T and K category. We have 37 in the K only. And we have 30 animals that are not tortoises or known. A. How many animals are there at this location? Well, in order to find the number of animals, we have to find our total inside the box. So we're going to start off by taking 4 plus 20 plus 37 plus 30. It's going to be 1. Looks like it's going to be 91. 91 animals. How many of these animals are tortoises? Well, we have 4 tortoises only and 20 that we know the gender of. So 4 plus 20 equals 24. How many of these animals do we know the gender on? Well, we have 37 that we know the gender only, but we know that 20 known gender and tortoises. So that's going to be 57. Next, how many of the animals of known gender are tortoises? 20. That's my center circle where the 2 circles overlap. All right, let's take a look at E. E says, find each of the following probabilities to the nearest thousandth. Use probability notation to write your answer. Suppose an animal of known gender is selected at random. What is the probability that the animal is a tortoise? So, known gender. So we got probability that we know the gender. We know the gender. I want to know what's the probability that it's a tortoise, knowing that we know the gender. Okay, well, let's see what that equaled. We know that there were 20 tortoises of known gender, right? And how many animals did we know the gender of? That was this circle, right? So 57. So 20 out of 57. I am getting approximately 0.351. 0.351. Now it says calculate the probability of K given T. We would think that this is probably the same, but it might not be because look at we're doing it in reverse here. We know the gender and that it's a tortoise, but we're given that it's a tortoise. So when we do this, we want to know how many tortoises do we have? That's my denominator. There were 24 tortoises. Of those 24 tortoises, we know 20 of them's gender. So we're going to do 20 divided by 24, which is approximately 0.833. Do probability of T given K and the probability of K given T represent the same region on the Venn diagram, and are the probabilities equal? And explain. They do represent the same region because it represents the 20, right? Probability of T given K and probability of K given T do represent the same area. but they are not equal because I'm going to drop right here and finish this up. The totals are different. Okay, one's out of 24, the other one was out of 57. Lastly, suppose a tortoise is selected at random. What is the probability that its gender is not known? Okay, so probability that gender is not known. So we're going to put K complement given that we know it's a tortoise. Let's take a look at this one. This one's a little tricky, I think. It's been a while since we've seen the K to the C, not something, not known. Okay, so what is the number of tortoises that we have? 24, right? How many of those tortoises do we not know the gender of? The 4. The ones that we only know are tortoises, we don't know their gender. So this would be 4 out of 24. And when we simplify that, it gives me 0.167. On to your final debriefing.